Self-hosted, ephemeral GitHub runners. That's the theme for this week. Hello, you're watching the development vlog for Shokken, a restaurant waitlist management tool that is currently available on Google Play Store and soon to be made available on iOS App Store. This is Bill from Shokken, and this is week 70 of development. The current status, as I just mentioned, Google Play Store has approved the app and it's ready and available for download and use right now. However, Apple iOS App Store has been giving me some issues, and I'm still addressing those issues. I do expect to provide my third submission for access to production by the end of next week, but I still have a couple of rough edges that I need to wrap up before I do the resubmission. The past week, however, the focus was self-hosted, ephemeral GitHub runners. And to provide some context, my CI/CD pipeline is pretty robust. Every time when I commit and push up my commit into a PR, a series of tests would run, and then when the PR gets merged into the master branch, another series of tests would run. Not only the tests, but also build verifications and runtime verifications and stuff like that. Of course, down the line, I'd like to introduce more and more robust tests, including integration tests, things that would have to run in an emulator and simulator. That is not yet done. However, the setup that I currently have is already quite heavy. And every time when a new PR gets published or merged, or when a new commit gets pushed to my repo, a lot of those GitHub Actions that are doing the verifications, which are required, in my case, I've required myself to have those tests to prevent myself from making mistakes and to prevent the AI coding agents that I've been using from making horrible mistakes as well, right? That's one of the things that you can do to secure your code base and prevent, data leaks, key leaks, and stuff like that. And of course, making stupid decisions for either you or the AI agent to make stupid decisions in your code base, because you have tests to guard against those. And as a result, every time when I do make a commit, it chews through a lot of minutes in my GitHub runner. And just to be clear that we're on the same page, a GitHub runner is simply a virtual machine of some kind of service living somewhere on somebody's computer that actually runs those tests on my behalf. If you're paying for GitHub, even if you're not, you have a certain number of minutes that they give you for free every month. And I believe the free tier, they give you 2,000 minutes, and the first lowest paid tier, they give you 3,000 minutes. And then, of course, you can always buy more minutes as your usage scales up. 2,000 minutes sounds like a lot of minutes. However, it really isn't, particularly if you actually have a robust CI/CD pipeline like I do. And you typically, for me, I chew through probably 2,000 minutes easy, even without macOS runners. Keep in mind that macOS runners cost 10 times as much. Even without those, I can chew through those minutes easily within the first week of every month during my development. So as a result, a number of months ago, I actually have an update for that as well. A number of months ago, I moved from GitHub runners to self-hosted GitHub runners. So GitHub, thanks to their design, they do allow you to host those runners yourself on your own hardware. And I have an old computer sitting in the closet that's not doing anything. So I set one up. Thankfully, it does have a lot of memory, which is something that you really need for like memory-heavy tasks that runners would have to do. For instance, the build tasks, right? It chews through a lot of memory. So fortunately, my computer is actually the idle computer that I'm using for this particular task is pretty powerful, and I set up a GitHub runner on that, and it's running pretty okay. I assigned, I believe, 100 gigabytes of storage to the virtual machine that's running the GitHub runner, and last week it ran out. After doing some investigation, I discovered that one of the biggest reasons that it ran out is because, the GitHub runner that I set up in my virtual machine sitting on a computer, the computer has a Proxmox host. And underneath that Proxmox, I have one virtual machine assigned to a GitHub runner, right? And the GitHub runner, of course, would use Docker to spin up the GitHub runners. But every time when Docker runs and pulls image and whatnot, it creates temporary files that are not really temporary, because unless you explicitly do cleanup, the files stay there. So over time, the junk would build up to eat up into the storage. And then last week, I started noticing all my CI/CD pipeline jobs started failing. And after I dug into it, realized that, hey, I had run out of storage on my self-hosted GitHub runner environment. I did some cleanup and then it started working again. However, it was never really a very robust setup, if you think about it. And that's really a persistent self-hosted GitHub runner is not the gold standard, if you will. I mean, of course, the gold standard is that you pay GitHub to do it for you, and to save on costs. I'm not there yet, right? I'm not doing it. I'm pre-revenue by about 1,000 years, so I'm not there yet. So self-hosting is the way to do it. Now, the gold standard for actually improving this particular setup is turning my currently persistent self-hosted GitHub runner into ephemeral, auto-scaling GitHub runners. So I'm going to explain the two concepts here. Currently, my GitHub runners are persistent. What that means is that the environment never gets torn down. Every time when this GitHub runner starts a job, it doesn't have a clean slate. It's whatever the state that the previous GitHub workflow job leaves it in. In other words, in all the workflow files that you would use to run through this GitHub runner, you would have to make sure that it does the cleanup and tear down at the end of every run, so that you don't have a state issue with the next run next time the runner gets used. That's okay. I did a lot of that, but of course, it would slow down a bit, because every time before it starts the job, it needs to do pre-cleaning, and then after it finishes the job, it needs to do tear down and cleanup. Adds a little bit of processing time before and after the actual work is done, but for my one-person shop, that's really not a big deal. But what is a big deal is, of course, that the junk file, or the junk files that keep accumulating, that keeps eating into the storage space, right? And that's not something that you can necessarily easily clean up from within GitHub workflow files. Because keep in mind that GitHub workflow files actually do not have direct access to the underlying system that it's running because of security. They can really only do things within the Docker environment. But if Docker itself is creating all the junk files, the workflow files can't reach through Docker to touch stuff in your operating system, right? That's by design. It's a good thing. But of course, that creates a problem with all the junk files. Now, if you really want to buy it once and cry it once, buy once, cry once, you can go straight to the gold standard of self-hosted GitHub runners, which is ephemeral auto-scaling. And these two are very important together. They are different things. Ephemeral just means that the environment, every time when a GitHub workflow runs and after the job succeeds, the entire environment gets torn down. And next time when a new job comes in, the environment gets erected again. So every time you have the exact same identical environment, you know for sure the workflow files would start at this baseline, right? You don't have to do cleanup. You don't have to do setup at the beginning, because you know what's already in the environment. And in the environment, you can specify, your Java version, your Android SDK version, all of that. It shows up for the work files. So that's very convenient, and you can control the consistency in between runs in this very well. So that's the ephemeral part. Auto-scaling part is the really fancy part. Currently, I have one fixed runner in my pool. And if I have multiple jobs, only one of them can go at any given time. This is okay in most cases. However, if you have multiple jobs running at the same time, and some jobs are dependent on other jobs, so they're spin waiting, right? So they're spinning, but they're waiting for the output of another job, and you only have one runner. It's a spin lock situation. You can't, none of the jobs can proceed at this point because, again, you only have one runner, and the one runner is tied up in the job that's waiting, and you don't have another runner to perform the tasks that are needed to unlock the one that's waiting. So that's it. And after some time, all the jobs would time out, and you'll get a series of failures. That's one of the biggest problems with non-auto-scaling single runner situation that I had. Now, obviously, there are ways that you can overcome this, which is don't spin wait, right? If you're waiting for some outcome, just quit and then have the following task workflow pick up, like wake you back up proactively, so that you don't have a situation where two jobs are waiting, like one job's waiting for another job. That's one design feature or design, I guess, compromises that you can make to prevent this spin lock situation. And the other thing that you can do, of course, is by using concurrency. And concurrency allows that all tasks in the same concurrency group to not be performed at the same time, so that you know that you can be sure that they're serialized as opposed to doing it at the same time, right? So there are neat tricks that you can do to overcome this limitation, but of course, ideally you would have more than one GitHub runner. The crude way of doing this, of course, is by setting up multiple GitHub runners and multiple VMs, and then each VM would actually take up however much memory you want to assign to the GitHub runner. And this is really not resource efficient. Now, for a self-hosted situation, if you have enough RAM sitting on your computer on your server, sure, you can do that. I mean, you're not going to use it for anything else. If you're not using it for anything else, that's okay. But of course, for an enterprise situation, you probably wouldn't be using self-hosted hardware. And even if you were, I mean, you'd be paying through your nose to buy all the RAM, right? So you would want to sort of scale it down when there's very light load, when there's, let's say, no job running. You don't want to consume any RAM, so that, AWS or whoever you're hosting it with, they don't charge you an arm and a leg for that. And then when jobs pour in, you would want to scale it to as many workers as needed to process the jobs faster. And that's the gold standard, or for if you want to do this yourself. The problem with this is, of course, you introduce a lot of complexity to this. For this to work, you have to use an orchestrator, somebody to listen in to the jobs being dispatched from GitHub runners, and then to distribute it to all the workers that you have underneath you. And this is not trivial at all. The two things that people typically do, they either use Kubernetes or they use K3s. And both are not trivial to set up, configure, maintain, and that's just a lot of overhead that I'm really not looking to have in this particular setup. In fact, my CI/CD pipeline is probably 99%. Well, I don't know. I haven't done a study or market research in particular, but for indie devs, I think I'm probably this product is probably in the top 10%, if not top 1%. So there's already a lot of overhead that I'm managing to ensure the security and integrity of the app. And adding on Kubernetes, that's too much. So what do you do in that case? What if you still want to enjoy the benefits of autoscaling and ephemeral runners, but don't really want to have to deal with Kubernetes? You whip it up yourself. And that's what I did. So the new setup that I have managed to accomplish ephemeral, the ephemeral quality of the runners. In other words, the runners are always fresh and they get torn down after every run. And I have accomplished some degree of autoscaling, but all without using Kubernetes. The way to do this, of course, is a little bit of scripting, not too much. And in my opinion, it's far easier than actually figuring out Kubernetes for this particular situation. What you do is, what I did is I have Proxmox, which is the hypervisor that's sitting directly on top of my hardware. So we install Proxmox, which by the way is free. The community edition. Thank you, community. Or thank you, corporation, for what you do to the community. And then within Proxmox, I have a virtual machine setup. For this one, I provisioned 24 vCPUs and 80 gigabytes of memory. And I'm using Ubuntu 24.04, long-term support, of course. And underneath the virtual machine, within Ubuntu, of course, you have Docker installed. And then what you do is you set up a systemd task that gets woken up every time when the system boots. And then that particular task wakes up, in my situation, 4 GitHub runners. Each, of course, all of them are under Docker, of course. Each of them is assigned 8 vCPUs and 16 gigabytes of memory. 16 gigabytes is important, and of course 8 vCPUs are important because a lot of the GitHub runners stuff that I'm doing are heavy tests as well as compilation verification. And these things can really benefit from a lot of RAM and a lot of processing, like threads in processing. So the systemd service would wake up all the 4 GitHub services under Docker, and then they would start listening. And as they're listening, they advertise to GitHub that they're available runners. And because I have 4 of them, I can auto scale up to 4. Now, this is not true auto scaling. In other words, like, my services are, all the 4 GitHub runners are still active, right? So you can't truly scale down to 0. But for my purposes on my self-hosted device, I don't really care if it doesn't scale to 0, because I'm not paying extra for keeping these things in resident memory as well as having processes running all the time, right? When they're not actually actively processing any particular workflow job, they don't actually occupy too much memory. They don't start allocating memory until they receive a job and starts creating the ephemeral image, right? So in other words, it scales down, but it doesn't scale down to 0, and it scales up to 4. It's actually fixed at 4, but the way to think about this is you can ask for 4 jobs to run at the same time, and my setup can take it. And that's the auto scaling part. And the ephemeral part is just in Docker. In Docker, you specify that after the Docker task is run, you kill the process, the Docker container exits, and then the restart policy is that you reset the Docker container. So next time it's not pulling from the previous state. You would cleanse the plate and then reapply the Docker container for the next job. So ephemeral part is achieved. And every time when you run something, you can be guaranteed that it's a new and fresh environment, and you don't ever have to worry about cleanup. So that's the setup for an ephemeral auto-scaling GitHub runner situation, self-hosted on your own hardware without using Kubernetes or any type of like hardcore level orchestrator for this particular task. And it's actually quite freeing. So I just set it up yesterday, and today, as I'm going through the development process, I noticed that all my jobs have started to be processed much more rapidly, because again, multiple jobs can run at the same time, all 4 of them. This is a very good feeling. And I foresee that I probably won't need any more than that in a long time, because typically when I'm doing merging as well as deployments, I have at most 4 jobs running at any given time. And then I don't think I would need any more than that. In any case, if you haven't tried it, Give it a try. It's worth doing. And it takes, I don't think it'll take you more than a day to have it set up, but it's well worth your effort. That's it for this week. I'll see you next week.